Hello and welcome to today's webinar, How North American Industrials Can Reduce Energy Spend with Demand-Side Management, presented by the ABB Process Industries Digital Business Line. My name is Audrey Wong-Gosselin, and I'm the Global Product Marketing Manager for the Sustainability Software Portfolio, and I'll be moderating today's discussion. In today's presentation, we're going to first start with an introduction to demand-side management. What is it and why is it important? Next, we'll get into the specifics in the North American energy market. Then we'll talk about how you can actually achieve demand-side management with the ABB Ability Energy Management System, otherwise known as EMS. And finally, we'll tell you some success stories from our own implementations of EMS with our customers. And at the end, we'll have an open Q&A with our audience, so be thinking about questions you'd like to ask our speaker. Without further ado, I'd like to introduce our speaker. Her name is Rosana Reyes Nava. She's the Digital Solutions Consultant for Sustainability within the Americas. Take it away, Rosana.
Thank you, Audrey. Welcome everyone to our webinar on demand-side management. Today, we will explore why managing energy demand is crucial for our future and how technology can help us manage it while reducing the uncertainty of cost. To understand why is demand-side management important, let's start by looking at the concerns of business leaders on energy supply to understand the broader context. A survey conducted by ABB on 2023 about this topic revealed that recent increases in energy costs are at the top of their minds, as they pose a threat to their profits and make them less competitive. One key reason for rising energy costs is an increased grid congestion. When the grid gets congested, extra measures are needed to prevent overloading that could compromise the grid security. Grid congestion can happen for various reasons, such as not having enough infrastructure or temporary events like extreme weather, which are most common every time. These can cause sudden spikes in electricity demand or supply, or even lead to equipment failures. A recent study from the United States found that the cost of transmission grid congestion more than tripled from $6 billion in 2019 to nearly $21 billion in 2022. One of the ways to solve grid congestion is to have a more flexible grid. For example, here we see that globally flexibility needs to increase, with huge increases needed in the US, China, and India in particular. And normally, we think of flexibility with regards to the supply side. For example, the ability to add more generation to the grid instantaneously when it's needed. But according to the International Energy Agency, demand-side response is expected to account for roughly a quarter of grid flexibility by 2050. Now, let's see what is demand-side management and how is this actually accomplished. Demand-side management, or DSM, as I will refer to it moving forward, refers to the strategies used to control and reduce energy consumption, particularly during peak demand periods. There are three main types of DSM strategies. First is energy efficiency, which refers to implementing any measure to use less energy for the same task. Then we have load management, which means moving the energy used to off-peak times to balance the demand when it is too high. On the third side, we have demand response, which refers to adjusting the energy consumption or any other variables like power factor in the short term in response to supply conditions like a compromised grid reliability during severe weather events. Demand response is often incentivized by the utility with financial rewards. Demand-side management brings benefits to both the energy consumers and the utility providers. On the one side, it helps reduce energy cost by financial incentives, reducing rates. On the other side, it enhances the grid reliability and prevents blackouts and brownouts. And a benefit for all of us is that there are also environmental benefits. because reducing carbon emissions by minimizing the use of fossil fuels during peak times. We'll now turn our attention to the North America energy market, where demand response and time variable pricing plays a crucial role in DSM, enabling industries to better align with their energy consumptions with grid needs. Let's see first what are the main variable pricing programs in North America. First, we have time of use or TOU rates, where prices move at set times and amounts throughout the day, generally with an afternoon peak period where energy is more expensive. Then we have real-time pricing, where the prices charged to the customers match either the underlying wholesale electricity pricing or the utilities cost of production. Similarly, there's day-ahead pricing, where the provider publishes its prices, which reflect the cost of acquisition or production for the following day, and the consumers can acquire some of this load at wholesale prices. Normally, real-time pricing and day-ahead hourly pricing are generally lower than retail or fixed pricing. Then we have block and index, sometimes also called block and swing. This is a combination of fixed pricing and real-time pricing, where the customer locks some of the load at a fixed price and then faces market pricing for additional usage. Now that we've seen some of the time variable pricing rates existent, let's take a look at how these models compare to the traditional fixed pricing programs in practice. This chart highlights the average wholesale electricity prices or real-time prices versus the fixed retail prices for industrial customers across three key markets. One is Texas, then California, and New England from 2020 to 2023. The first takeaway is that wholesale prices generally tend to be lower overall, especially during low demand periods. However, they are much more volatile, as we can see here on this sharp spike in Texas in 2021 during the winter storm, when prices skyrocketed. On the other hand, fixed retail prices provide stability, but as you can see in every region, they are consistently higher over time due to the need to account for risk and market volatility. Another takeaway we can take is the growing divergence between wholesale and retail prices over time, especially in regions like California and New England, where grid constraints and the renewable integration drive up fixed retail prices. This highlights the potential value for industrials entering in real-time pricing programs, where they can respond quickly to market fluctuations to lower their cost. These three regions, Texas, California, and New England, are among the most popular for time variable pricing, and they give us a good snapshot of how these pricing models impact industrial customers. However, in the next slide, we'll take a look at the bigger picture across North America to see where these programs are available. Here is a general overview of the US states, Canadian provinces, and Mexico by availability of time variable pricing programs to industrial customers. In general, the darker, the most programs and rates are available, prioritizing real-time and demand response. From the US perspective, the majority of the US utilities offer their commercial and industrial customers at least some kind of demand response and time variable pricing. These programs reflect the dynamic nature of electricity availability, delivery, and production. These costs can vary significantly over time, even every few minutes. The programs provide incentives for electricity consumers that can manage load by encouraging load curtailment and shifting. Customers can gain substantially a lot from participating in these options, especially if they can adjust their electricity usage occasionally in response to market signals, such as demand response event notifications or real-time price fluctuations. Now, let's see some numbers about participation. In the US, customers participating in time variable pricing programs have been relatively low but growing steadily. In 2021, the federally The Federal Energy Regulatory Commission estimated less than 10% of industrial customers participated in real-time pricing. Now, demand response participation has been more significant. According to the U.S. Energy Information Agency, in 2020, about 30 to 40% of large industrial customers were enrolled in some form of demand response program, and in regions like California and New England, where programs are more mature, participation was up to 45% in 2022. Even though growth has been increasing, there is still a big gap and room for improvement, considering the potential that these programs can offer for cost reduction. For example, according to a study from 2019 of the Smart Electric Power Alliance, customers that switch to time of use can reduce energy costs to 15 to 25% and going up to 30% with real-time and day-ahead pricing. This is not even considering in demand response or energy efficiency program benefits. This gap between the availability and the adoption suggests there is a need for more education and support to maximize these benefits. And at ABB, we believe that digitalization can provide some of this support by enabling customers to manage their own energy usage. Now, let's introduce our ABB Ability Energy Management System, a software solution that can help industrials with their DSM strategies. The first step for demand-side management is to know how much, when, and where is energy being used around the site. Our Energy Management System, Module 1, provides rich online monitoring and reporting features that will start to generate awareness across the organization, not only on electricity, but also on other energy types such as water, air, gas, and steam. Energy management provides a hierarchical structure for understanding and breaking down cost and consumption structures, allowing to set up targets at areas and department levels and to follow up on improvements. Once these have been done, then energy analysis capabilities can help with detecting consumption patterns for improving energy efficiency. Now that a blueprint of energy consumption is created with Module 1, the next step is to forecast and plan energy usage with Module 2. In this module, we will help to plan for the right level of purchase in the real-time day-ahead market, avoiding demand charges or penalty charges due to peak consumption, and designing the most effective production plan given the different energy prices and energy constraints. Now let's see how is this done. First, for every energy consumption unit, which could be an area, an equipment, or a system, we model the energy consumption pattern. EMS supports various forecasting models, as seen in this slide, from the most simple constant load to more complex user-defined functions. When all of this is aggregated together at the plant level and the user enters their input variables such as production plan, process sequence, or maintenance events, such as a shutdown, what you will see is a forecast of energy per process, area, or equipment for the next week, days, or even down to 15-minute periods. This enables users to do things like conditional scenario simulation. For example, what if a circuit stops? What if we double the production or we move some of the production to an off-peak period? What we are seeing among our customers is a trend to include energy into production planning scenarios. What used to be a necessary operational cost in the past is now an important variable that can help optimize expenditure and therefore making our customers more profitable. And this is the next logical step. Leveraging energy price fluctuations, process flexibility, and advanced computing power to explore every possible scenario and identifying the optimal solution that meets the production need with the minimum energy cost. This is what energy optimization is about in Module 3. Another use for optimization, which is not part of demand-side management, but can also be leveraged to reduce costs, is energy source procurement strategy. For example, if a customer has a battery system or a solar panel system, EMS would take advantage of those to optimize the energy that is procured from the grid and the other systems based on availability, prices, and any other targets such as CO2 emissions. Now, let's see some of the stories of our customers implementing EMS for demand-side management and how they have obtained successful results in managing their energy cost. For example, this steel plant in Switzerland, they implemented ABB EMS to send the predicted load schedule to the electricity supplier and to monitor their actual consumption. The energy management system received the production plan of the steel mill and the hot rolling mill from the production planning system and calculated the corresponding energy consumption schedule. The biggest consumer in the steel mill is the electric arc furnace, whose load changes sharply between zero and the maximum power during a melt cycle, which is around 50 minutes. During this electric arc furnace operation, the load schedules exhibited a very strong time variation. And if this consumption schedule wasn't correctly predicted, the electricity supplier was incurring into additional costs due to grid congestion, which then were transferred to the customer in the form of penalty charges. To avoid these penalties, any changes in the production plan or disturbances in the operations were continuously updated in the energy management system, and the revised load schedules were sent to the electricity supplier in advance. Operators would then monitor the consumption using the timeline monitoring display that activated an alarm if a deviation leading to a penalty charge was expected. The energy management system also allocated the energy cost to every user, in this case, every department. The penalty fees were shared among the departments that caused them by not consuming the energy according to their schedule. This motivated every department to improve their planning of their operation and resulted in reduced energy costs to the entire facility. With this implementation, the customer was able to accomplish up to 5% in reduction of the total energy cost. Now, let's turn our attention to another compelling success story from a leading company in the paper and packaging industry in Austria. This facility faced significant challenges in managing energy consumption due to high cost and a fluctuating demand pattern. An analysis of their operation revealed the need for a system that could optimize the usage while also accommodating the complexities of their production. To tackle this issue, they implemented ABB EMS, and a key aspect of this solution involved participation in the real-time energy market. Our team analyzed their process and identified that the refined mechanical pulp was an energy-intensive step that exhibited some operational flexibility. This means that they could schedule it at different times of the day. The EMS was designed to shift this operation to periods where the electricity prices were lower, leveraging a connection to the real-time market data, production targets, and other process constraints. The dynamic adjustment of the process optimized the energy consumption without compromising the production efficiency. The implementation of this system yielded substantial benefits. We estimate that there was a potential for nearly 15% of savings during high price volatility periods. And this customer was very satisfied, as we can read from this quote. I know companies offering similar products, but in my opinion, the ABB one is the best. This concludes my part of the presentation. Back to you, Audrey.
Okay, everyone, now we are going into our Q&A section. Now, I've already got a couple questions that are coming in, but
before we get to that, and while you all are thinking about what you want to ask and writing it down, I do have some questions for you all. You're going to have a couple polls that are going to show up on your screen right now, okay? So the first question that I have for our audience should be popping up right now. What is your primary goal with managing energy? Is it cost reduction, achieving internal ESG goals, complying with external regulations, energy billing, anomaly detection, or something else? All right, let's move on to the next one. Now, my next question for you all, coming up now, how does your company monitor energy consumption and billing? Are you doing this very frequently? So intraday, maybe in 15, 30, 60-minute time steps? Just frequently, which is maybe daily or weekly? Regularly, so at least monthly? Occasionally, every few months, quarterly, or rarely? Just annually, maybe you're looking at your end of year reports, or not sure. Okay, give you a few more seconds on that one. All right, let's move on to the next one. At what level are you monitoring your energy? Oops, here goes. And now it should show up. At what level are you monitoring your energy? At the enterprise levels, maybe multiple sites, the plant level, just the entire single site, an area or a process sub area within a plant, all the way at the equipment level, or not sure. A couple more seconds. Okay, great. Next question, how familiar are you with the demand response and or time variable pricing programs in your region? Are you aware and you participate in the programs? Aware but you don't participate in the programs? Or not aware? Okay, a few more seconds. All right. Moving on to our last question here. What is your biggest challenge with forecasting your energy needs? Is it a lack of data, unpredictable production plans, limited resources, inaccurate forecasts, integration with other systems, or other, something else? A few more seconds here. And then we'll get into our Q&A. And I see we've got even more questions coming in, so fantastic. Okay. Thank you all for participating in that poll. All right, so let us look at some questions. Here we go. Let's take a look at this one. So we have got a question that says, I don't have an ABB control system or energy meters. Can I connect EMS to my system?
That's a great question. The short answer is yes. Typically, whenever we encounter a fresh installation of energy management, there are either some ABB legacy systems like a DCS, a Historian, but there are certain energy meters that are non-ABB. And our EMS, it's platform agnostic, so we can communicate to most of these equipment as long as they are within some of our communication protocols, such as OPC, Modbus TCP/IP, which is very common. And in some very extreme cases, we have implemented other communication protocols and even manual data inputs when the data is not real time.
Perfect. All right, let's see. Here's an interesting question that we've got about that market information that you showed. Someone says, you showed less than 10% participation in real-time pricing in 2021. Why are adoption rates still so low?
Well, from my experience talking to customers and whenever we talk about demand side management and variable time rates, the most common answer or the most common challenge that customers say is that they are not open to facing the risk of the variable pricing, or if it's demand side or demand response, when they get this message, or if they get this message that they need to reduce energy, they just don't have the flexibility to reduce the energy. And that's a little bit where we think digital transformation can help. Digital transformation in energy management can help to overcome these risks, to be able to first have data to let people see where you can actually have flexibility, and then to respond rapidly to these real-time market changes in pricing or real-time demand response signals that used to be less automated. Now we can automate this. And one other thing is that now with the computing power we have, the pricing of these solutions and the implementation of these solutions are more at hand of our industrial customers, and the return of investment is better than it used to be before. Before, probably implementing things like these would really not bring the benefits that the savings would bring. But now we are seeing more and more that return of investments are shortened to 3 years, 5 years, even in many cases. Depends a lot on the benefits, and that varies from utility, from state to state, but it can even go down to 1 year.
Gotcha. Okay, we've got another question I think is similar, but I'll share it anyway. So what is the main barrier you encounter in implementing DSM with industrials?
It's quite similar. And as I mentioned, the first one is that our customers say, "Oh, I don't have flexibility. I cannot stop my project, my process, or I cannot slow it down." And that is true in most cases, or in some cases. But in some cases, it's not lack of flexibility, but it's more lack of transparency. Because most customers only have measurement of energy at their plant level. Once we do a blueprint, as I mentioned in the presentation, of where are you consuming energy, what equipment is consuming energy, and at what time you're consuming energy during the day, then we're able to say, oh no, actually yes, we can reduce this much megawatts during this time when it's required by the utility. And then on another side, when this is entirely not possible, because definitely you cannot move your production, there is microgrids. As I mentioned, if there's a possibility to install things like a battery system to charge your batteries during load prices, and then use that load on your plant during the peak prices or during the demand response. This is not exactly demand side management, but this is something that can be used from the demand side to address the lack of flexibility. And EMS can help with that as well, to control, to orchestrate all of this.
Got it. All right, so I've got another question also from Wada. Actually, I'm going to ask you, can you possibly retype this question? I'm not sure what you're asking. Can you share a tool to estimate potential cost savings? I'm not sure if you're talking about EMS or a different tool, but while you maybe respond or rewrite the question, unless Rosanna, you understand what they're asking.
Well, I guess that, and feel free to elaborate, but maybe they want to understand if given a few inputs, we could tell them how much energy or money they can save using this? The answer is yes, we do have in some cases tools to estimate savings, but some of the inputs require a lot of details on the contract rates and the programs that you are participating. We also have a lot of information from, for example, for the US. If any of you are interested, we have a database of all the demand response and time variant programs for all the utilities. This is publicly available. If you're interested, we can share the link. And taken that and your current status, we can definitely share based on your current process how much you could potentially save.
Yeah. I think you got that, Rosanna, what they're asking for. But yes, this is something that we can help with, but it's probably going to take more of an in-depth conversation, understanding your operations, so that we can get, actually a good estimate. We can do very like back of the napkin estimates on energy savings, but unless we kind of better understand your operations, it's not very accurate. But if you're interested in that, we'd be happy to chat with you. So you can contact us, or we can also reach out to you directly after this. But we have reached time. So at this point, I think we're going to close our session. I want to thank Rosanna again so much for sharing your insight, presenting, and thank you all to our attendees for participating, for these great questions. And we'll talk to you again soon. Bye, everyone.